Chapter 12, Section 2 in the 8th grade textbook is entitled Slope of a Line. So if you recall in 12.1, what we did with graphing and specifically lines is we graphed everything that involved us using the table method. Now they're really going to start getting into ideas that involve us graphing that relate specifically to having the slope of a line. But before I can get you into ideas that involve directly graphing with the slope of a line, I have to teach you what slope is. So that's where 12.2 is going to take us here. The objective here is to find the slope of a line and use slope to understand and draw graphs. So let's go ahead and start with that third definition there. What is slope? Slope is the ratio of the rise to the run for any 2 points on a line. As we've talked about it, it's the rate of change that compares how much a line changes in y versus how much a line changes in its x values. If you want, you can think of it as how steep a line is or how steep a line may not be, how much tilt that line has to it. Whatever you want to, that's what slope is. Now there's two components there in the definition, rise and run. That's what those first two definitions are there. Rise is the difference of the y values of the 2 points on a line. Run is the difference of the x values of the 2 points on a line. If you remember when we looked in 12.1 at constant and variable, and we looked at having that table and figuring out from that table if what was there was a line or not, how did we do that? Well, we compared the change in the y values to the change in the x values. And that's the reason we did it in that order, is because all of a sudden this idea of slope is going to look at the change in the y values versus the change in the x values. So that's exactly what we're going to do. We're going to look at slope. To figure out the slope of a line, we're going to look at how much a line changes in its y values and look at how much a line changes in its x values. So let's go ahead and look here at number 1. In number 1, they're asking me to find the slope of the line. So what you want to do is identify a couple points that are on that line. And as you can see in this particular question, they've identified 1, 2, and 7, 5 for us. You can pick anything that's on that line. That's just happened what they've picked. Slope, again, was defined as the change in the y's over the changes in the x's, or, to put it simply, the rise and the run. So what you want to do is calculate the rise and the run that would be involved in traveling between those 2 points. You always want to start at the point that's on the left and then go over towards the point on the right. So I'm going to start over here and end over here at 7, 5. Well, if I start over here and I'm going to go over there, the first thing I'm going to have to do is go up 1, 2, 3 places to get there. So the rise here is going to equate to 3, which is what you can see they're figuring out right here. Then I have to figure out the run. The run is going to be how much I'm going to have to move to the right to get to that point. Well, in this case, I'm going to have to put 1, 2, 3, 4, 5, 6 jumps to the right to get there. So the run is going to be 6, which they have right here. So the slope here is going to equate to 3 over 6. Now that is a fraction that is reducible. You can reduce that down to 1/2, which is another way to express the slope here. You do pretty much want to leave slope as a fraction all the time. Even if it was something like 2 over 1, which you could simplify to 2, still you really should write it as 2 over 1. The reason I want you to do that is because I want you to remember that there's a rise and a run involved. Sometimes if we start reducing those fractions like 2 over 1 and taking the 1 out, sometimes we make the mistake and forget there's a run involved. There's always a rise and a run involved unless it's a horizontal or vertical line. So the slope of the line picture is 1/2. Now, here's the thing you need to know. If the line goes down like this, we're always still going to go from left to right. So that run number is always going to be positive. But if the line points down going from left to right, obviously the rise means we're actually going to have to go down, which makes the rise turn into a negative amount, which means the slope is also then going to equate to something that is negative when we're done. All right, let's go ahead and continue on here. And we're going to take a look at number 2. We're asked to find the slope of the line that passes through -2, -3, and 4, 6. Well, you've got some options here. You could, if you wanted to, go ahead and lay those points on a coordinate grid like we did back up here in example 1, and then count it off and find the rise and the run, and that will, of course, equate out to your slope when it's done. That's an option you have. But what they're actually doing here, and it's actually written down for you, which is nice so you don't make us go looking for it. Right here, they've actually given us the formula for finding the slope given a set of points. The formula says I'm going to take the difference of the y values and divide it by the difference in the x values, and that's going to be my slope. And we've seen this y2, y1, x2, x1 before. We saw it in the distance formula when we were finishing up the last unit when we were working with Pythagorean theorem. Here it is again, but now it's in the context of slope. So let's go back and refresh our memory here. Points are always written x comma y. So here I have two sets of x comma y's. In -2, -3, -2 is an x and -3 is a y. In 4 comma 6, 4 is an x and 6 is a y. So I got a couple different sets of x's and y's, which accounts for that part of those in the formula there. Remember, the 1s and 2s simply means it's either the first set of numbers or the second set of numbers. So they decided they wanted this to be the first set of numbers, so we throw some 1s on it. They want this to be the second set of numbers, so we throw some 2s on it. And so now we see where x1, y1, x2, and y2 come from that we're going to now go plug into this formula. So the formula says to find the slope of the line that runs through the points, I'm going to subtract the y values, second set from first set, so 6 minus -3, which is of course 9. And then I'm going to subtract the x values in the same order, 4 minus -2, which is 6. And then I'm going to take this fraction and reduce it. And that's going to reduce down to 3 over 2. And so I give 3 over 2 as the slope of the line that runs through -2, -3, and 4, 6. Go ahead and graph it out if you don't believe it. Graph it out, calculate the rise, calculate the run, reduce it if you need to. You're going to see that the slope of the line that runs through those 2 points is indeed 3 over 2. We also know, because this is positive, that this is somehow going to be a line that tilts up, not a line that tilts down like this. And that's another option you have here tonight now when you're finding the slope. If they give us 2 points, we can use the formula. Even if they draw it, we could come back here and just write the points down and plug them into the formula to find the slope if we didn't want to sit there and count them out. Especially if it was something like between grid markers, like halfway between a grid marker or a quarter of a way between a set of grid markers. Might be easier to use the formula than sit there and count them off, half grid boxes, quarter grid boxes. Probably have less chance of making a mistake using the formula, especially since we have those calculators available to us. Alright, so let's go ahead and take a look at number 3. Number 3 says the table shows the total cost of fruit per pound purchased at the grocery store. Use the data to make a graph, find the slope of the line, and explain what it shows. So as you can see, we've got this table here that's comparing pounds and costs. Now the problem is we don't have labels on the coordinate grid that relate to pounds and cost. All we have are x and y. So what they're explaining there in that little chunk of data underneath the table there is they're going to go ahead and let pounds go on the x-axis, and they're going to go ahead and let the cost go on the y-axis. So I'm going to come down here to my table, and I'm going to change pounds into x and cost into y. Alright, so here we go. Here's our graph, the exact same graph you have in your notes there. I've just blown it up so it's a little bit easier to see, because there are some, it's a pretty small graph there. With the increments they've decided to use, it's even harder to see. So we're going to go ahead and graph. These are my x values, these are my y values. As a refresher again, this is my x-axis, this is my y-axis. So I'm going to match up from there. Now the first one is really easy, and it makes a lot of sense. It says if I don't buy any fruit, I'm not spending any money. That makes sense. So that first point is right here at the origin, which on this graph, the way it's drawn is towards this bottom left here. Remember, the origin is usually in the middle when we show all 4 quadrants. This is only quadrant 1 of the coordinate grid. For 5:15, I'm going to go to 5 pounds on the x-axis, which is 1 jump over because it's going over by 5s. And then I'm going to go all the way up to 15 on the y-axis, which is right here. And those two meet right at this point, so that's where this point comes from. So if I buy 5 pounds of fruit, I end up spending $15. The next one, 10, 30. So I'm going to go over to the 10 mark on the x-axis and all the way up to 30 on the y-axis and find where those meet, and that's right here, so that's where this point is. Now, my next marker is actually off the graph, but we could figure it out. 1545 means I'm going to go over to 15 on the x-axis, up to 45 on the y-axis. Those are going to meet around here. That's where that next point would be. And so there's the graph based on this table. So now, what they want us to do here is extrapolate the information here. They're asking us to find the slope of the line and then explain what it shows. Well, let's use the easy ones to work with here. Let's go ahead and use the 0, 0 and the 5, 15 from the chart to help us figure out the slope. The slope formula, again, says take the difference in the y values. Well, my y values here are 15 and 0. And take the difference in the x values, 5 and 0, and subtract them and divide. And as you can see, then they did that. 15 divided by 5 changes into 3. So the slope here is 3. And not only were we supposed to find the slope, we were supposed to explain what the slope means. Well, remember, 3 actually means 3 over 1. Remember what this top number means. The y values were the cost, so we could come back here and label this cost. Right? And this bottom number, 5 and 0, the x's, those represented pounds. So if it works out to be $3 in cost per pound, or in other words, the slope in this particular table and graph set here means that I'm paying $3 for every pound of fruit. And that's the explanation of slope there. 3 over 1, $3 in cost per 1 pound means I'm paying $3 a pound for fruit. All right, let's go ahead and take a look at the concluding example, the check it out question here. The check it out question here asks me to find the slope of the line first that's graphed here. So again, we're going to calculate the rise and then calculate the run, and that's going to equate to my slope. Now again, you need to pick some points that are on the graph, and it would be obviously a lot easier if you pick points that go through grid markers. So for instance, I see this point right here at 1, 1. That looks like it's going through a grid marker. That would be fairly easy to count. And then I see another grid marker right here where the line goes through at 2, 3. So that's what we'll use. If you wanted to pick something else, like maybe you saw this one down here and this one up here, it's fine. It's not going to hurt anything. You'll end up getting the same solution when it's done. Trust me. So I'm going from here to here. Again, I've got to calculate the rise, and then I'm going to calculate the run. I want to do it in that order because slope is rise over run. So to go from this point to this point, because remember, we're always going to go from left to right, first thing I'm going to have to do is go up 2 units. So my rise is 2, and then I'm going to have to jump over 1 unit, so the run is 1. So the slope of the line that connects those 2 points is 2 over 1. And as you can see, they wrote 2. Again, I would write that as a fraction just so we don't ever forget there's a run. But 2 over 1, or 2, is the slope of the line. And number 2, they're asking me to find the slope of the line that passes through -4, -6, and 2, 3. So we can jump into that here. Again, that formula that you saw earlier says take the difference in the y values first to find the slope. So I'm going to do 3 minus -6 and divide that by the difference in the x values, 2 minus -4. Well, when I simplify this out here, I'm going to get an answer that's probably exactly like the one they already have there, 3 over 2. Well, let's check it out. Minus a negative, both of these. You already know minus a negative changes into pluses. So this is really 3 plus 6 over 2 plus 4. 3 plus 6 is 9, and 2 over 4 is 6. 9, 6 is a reducible fraction, and it reduces to 3 over 2. That's my slope. 3 over 2 was the answer, so that makes sense. So the line that runs through -4, -6, and 2, 3 has a slope of 3/2, or 3 over 2.